Welcome everyone. Let's take a closer look at lunar eclipse review. So hopefully you're at a point in the class where you've gone through material with lunar eclipses. That term means something to you, that you understand the difference between a lunar or a solar eclipse. You should be at a spot where if I asked you why they occur, when they occur, why they don't occur every month, why there are different types of lunar eclipses, that the gears start turning and stuff comes to mind. But let's just kind of start with some basic review. If this is the sun and we live on Earth, we know that we're revolving around the sun or orbiting around the sun, and that the moon orbits around the Earth, right? And that means that, as it makes its way around different angles, we'll see different portions of that illuminated half giving us lunar phases. There's a time then that the moon would be closest to the sun, or I guess the way you could say that is the moon is between the sun and the Earth, and obviously the side facing the sun is going to be illuminated. The side closest the Earth would be in darkness, so we would see this as a new moon or a dark moon. It's kind of one of those ones where this is how the far side of the moon is not the dark side of the moon. Sometimes kids will think, well, it's a long ways away, it must be darker. Not necessarily. If the side farthest from us is facing the sun, it'll actually be the illuminated side. And then if we put the moon over here, and I guess kind of like the other extreme situation where it's like farthest from the sun, the half that's facing the sun would be illuminated. The dark side of the moon would be the far side of the moon. We would view this guy as a full moon. So we know that the orbit that the moon makes around the Earth, like if I were to kind of draw this like this, all right, there's the Earth, and I were to say, that's the path that the moon goes on. And then here's like your full, and here's like your new, that it's actually sort of like that without, pulling out a protractor. In other words, there's that 5-degree tilt. And that's going to mean that a lot of times when we get a full moon, the Earth's shadow is just cast off into space, or the full moon is above or below it. Sometimes though, it works out to where the Earth's shadow can fall on the moon, or the moon passes through the Earth's shadow is another way of saying that. That would give us a lunar eclipse. Sometimes, like we're going to see next, is the moon shadow could fall on the Earth, and that would give us a solar eclipse. But we're going to save the solar eclipses for their own part. Hopefully that gets your gears kind of thinking, and you're like, oh yeah. And I recall that there are two parts of shadow. And I tried to just sort of show you a slide that was similar to the one that I had in lecture, where you've got this larger area of shaded area. It's kind of like lighter shadow. And the term for that is the penumbra. And then you've got the smaller area that's completely blacked out or completely darkened. That would be the umbra. And the way I kept that straight when I was a kid is I was like, look at this. The penumbra is the bigger word. The penumbra is the bigger shaded or shadow area. The umbra is smaller. The umbra is in the penumbra. So umbra is in penumbra, and that smaller area is going to be the all direct light blocked out. This is kind of like, again, in shadowy area. So it's a less shadow, maybe it was a way of thinking of it. So you kind of have like three things that could occur, right? You could have the moon pass just through the Earth's penumbra. That would give you a penumbral eclipse, penumbra, because it goes through the penumbra. Kind of makes sense, right? You could have where it goes through part of the umbra and part of the penumbra. That's referred to as a partial lunar eclipse. And you could have where it goes into the umbra. It's totally in the umbra, and that would give you a total lunar eclipse. And you might be thinking, Cash, you dirty dog, you lazy son of a gun. Why didn't you write penumbral lunar eclipse or partial lunar eclipse? I suppose I probably should have, but when we get into the solar eclipses, we'll see that we've got different guys that can happen. But for now, you know, should I have? Okay, but we're just focusing on lunar eclipses. So there you go, I did just solid. I just wrote it up there and you don't have to jot it down twice. Looking at that, if we had to describe where these guys would go to get a penumbral eclipse, you're located in the Earth's penumbra. And if somebody said, okay, how would that look? How would it appear? I'd say it's kind of dimmer. Maybe some reddish color. Usually it almost looks like there's just like kind of overcast, or it's sort of like a cloudy night. To be honest, the nights that I've gone out and seen some penumbral lunar eclipses, if I didn't know that that's how it worked out, I would have just thought it was a full moon. I'm not trying to, you know, poo-poo them or totally bag on penumbral eclipses. They're just not really all that fantastic. So partial, that's where you're gonna have, I could just put both, right? Or if you wanted to put the penumbra and the umbra, that's fine. So this is oftentimes described as looking like a bite is taken out of the moon, or you've got like an odd moon phase. I could have said an odd lunar phase there, but you know, a lot of times what you'll have happen is here's the moon, and you get sort of a shape like this, where it almost looks like you've got kind of a crescent moon that's bigger, almost like a gibbous, but like flipped over. And you know, if you think about it, here's the moon going through the parts of shadow. This up here would be like the penumbra. This down here would be the umbra. Or if we look at these little guys, right? So this part down here that's actually in the umbra, that's gonna look a lot darker, but it's sort of like a weird lunar phase. And then the total, you really kind of get everything, but we're talking about totality, or like when the moon is in totally the Earth's umbra. So during totality, we'll say in the umbra, and this is where you get that phenomenon of refraction that makes the moon turn dark red. And we've discussed now, you know, well, hey, if this area is so darn dark, why the heck isn't it just black? Or it almost looks like you went from full moon to new moon. And those are good questions. But we know that the Earth's got this layer of gases around its surface called an atmosphere. And even though this is the blocked out area, these upper areas of the atmosphere refract or bend the light from the sun. And you know, we know that from when we talked a little bit about the electromagnetic spectrum, you've got your Roy G. Biv, that these higher frequency guys don't bend as much. The red slows and kind of gets warped down. Long story short, some light gets bent through the Earth's atmosphere and falls on the moon. And it's the red frequency that makes its way through onto the moon, giving it that dark reddish rust-like color. So that's a quick and dirty review on lunar eclipses. If there's something you still need some clarification on, please don't hesitate to reach out. Till I see you again, bye-bye.